The first thing I wanted to go over today before we walk through the PowerPoint is this Chapter 5 drawing project. Because it's real easy. It says to use the exercise on page 551, which is exercise P5-17, to create an offset section, and that's doing it by hand. Well, here's what the page looks like.
Okay.
So all you'd be doing is this offset section AA. If you want to do it in the workbook, you can do it in the workbook, or you can do it on a separate sheet of paper. But if you do it in the workbook, the thing's basically outlined for you already, right here. All you got to basically do is draw it and fill in the, what should be solid, and then put the section lines in. And I don't think it calls, it says that the material is steel. When you read the instruction, I couldn't get that in the photo over here, but so that means you got to draw the section lines that are specific to steel. That's basically just a double line, then a bigger space, and another double line. And when you do them, they should be in line. So in other words, if you start on a corner here and go off at a 45, when you start drawing lines here, they should transfer down to here as well, and so on. And so forth, so that they're not kind of catty, they're not jumbled up, and there's no organization to them. But the line should just keep flowing this way, and then of course when you run out of space, when you run out of space up here, you continue over here, and then if you can't make a continuation, say out to here, which is this is where the section lines are going to be, you just start again. And then just keep moving all the way up. So it's pretty easy. Shouldn't take any time at all to accomplish, even if you happen to draw it on a separate sheet of paper. But my suggestion, I guess, would be to draw it, do it in the book, take a picture just like I did, and submit that. 'Cause I'm pretty sure that's what the submission is. Either a JPEG, a PNG, or a PDF. So that's only a 5-pointer, so it's not a huge deal, I guess, if you don't do it. But 5 points is 5 points. And then the other homework assignment that's being given to you today is just answering some questions in Chapter 7, which you probably started already last week, 712 through 728. And again, I give you guys the option of a text entry box. If you're not filling out the questions by hand, you could actually type them, and questions and answers in a text entry box and submit it that way. That's mostly for the guys that are trying to save their books, I guess. I think I'm being overly generous to them, but in any event, those are the two assignments that you're being assigned today, and of course the quizzes. I'll have the May 6th due date, and again, I'm trying to update these. The dates on these projects as I go, homework assignments and what have you. But I'm still putting the 1-week due dates in. I'm just leaving them open until May 1st. That at least gives me some time to try to catch up on everything. All the last minute submissions. So I'm still putting the regular due dates in, but you got till May 1st to get them done without any penalty. But the assignments, like the quizzes, are going to shut off on those drop dead dates, the May 1st and May 6th. Everything's going to shut down, so you won't be able to submit anything after that. You guys probably know all that. So if it's just the two of you, let's what do you guys want to do? Do you want to go over the PowerPoint? Have you looked at it?
I'm not sure. I looked Well,
Yeah,
might as well look at it. Yeah.
let's take a quick look at it and see if um, there's anything new here. Basically, we're going to be talking about advanced sectioning, which is going to include auxiliary views, partials, and details. Interesting part that they have here, it kind of shows everything. I've got a part that I've got pulled up that we can show how to do an auxiliary view. I mean, it's pretty easy in SolidWorks. So this is a detail, wherever my cursor's at, right here. Just basically, you outline a portion of the part. And I kind of demoed this last week, I think, last Monday, with a part, with that offset section part, or what part was it, where I showed a little bit of a detail. I forget what part it was.
It was that little thing, was that little conical shaped thing that we had to make the half.
Oh, yeah, that's right. That's right. Yeah. So again, this is not anything earth-shattering either. When you start the command, SolidWorks tells you to draw a circle or something around the, I think I use a circle as a default, in the area that you want to detail. And it automatically scales up a view for you, and you can change the scale on the view if you want. But this is what a detail is. It scales up a portion of the part in order to allow you to detail it better. You might, in this area on the whole part, with all the other surfaces and features you have to dimension, adding dimensions to locate all this stuff would be kind of a mess. So you pull out a detail and blow it up, and then you can dimension what you need to dimension, with a lot more clarity. A partial section, like they're showing here, and here is just basically, this one looks like it's a partial from the bottom view of this hole, so that you could maybe dimension the location of the hole or the size of it, since it's obscured up here as well. And then, of course, a partial of this area right here in order to maybe detail this thing a little bit better. A partial auxiliary, and it's an auxiliary view of this flat surface here. Again, the top view, it's foreshortened, and in the front view, it's foreshortened also. So you need to create an auxiliary to show a true size, and you wouldn't really be able to dimension this slot very well from any one of these views, because your dimensions are two-dimensional on the flat surface. So if you were dimensioning, I guess from here to here, it'd probably be okay, this way, because this edge is from here to the centers of the slots is the same regardless of what angle it's on. But if you dimension from here to the center of the slot, a linear dimension is going to be a vertical dimension from here to here, not going to be the true dimension. This is going to be shorter from here to the center than it is from here to the center, because it's foreshortened. You're just coming down. Yeah, it might be close, because it'll probably try to come down to here, but most likely it's going to pick up this point right here and bring it over and go up like that. So that's, if you were to measure that in SolidWorks with the measuring tool, that's what it would do. It would show you that straight line dimension, then it would also show you the true dimension. I'll see if I can demo that for you guys. Again, we're not going to do too much of this by hand, but it's good to know. So we talked about auxiliary view. Most of this I talked about already. It's created on a projection plane that's not one of the 6 principal planes, right? When you got a part with an angled surface. So it allows you to show it all at true size. Here's a full auxiliary of this part. Here's a partial. If we don't need to show all this stuff necessarily, then sometimes it just confuses the issue. So you can just show a partial to kind of eliminate this and clean up the view. Because probably all you're really interested in is the location of this counterbore and hole, whatever, yeah, counterbore, countersink, and the hole. So you're probably just, that's probably your main thrust is location and size of this stuff. Okay. Now this might be a slide that we that they might have showed before. I don't recall. Looks familiar to me. Not that I haven't seen it for the last 4 years, twice a year, but in any event, a partial section. No need to show the whole, or excuse me, a partial view. No need to show the whole thing necessarily. In this case, it's probably not a big deal, but if you're pressed for space and you only want to show the location and size of this hole and this radius, that might be the way to go. Eliminate all the geometry that would be up here. They have their uses. Showing so pertinent features. Detail, we kind of talked about that already, right? Zooms in on a small portion of the part and uses to highlight small features and make it easier to dimension. Again, like I said, you've already got a ton of dimensions in this area as it is, and if you're trying to add all these to that view right there, it'd be kind of busy. So this way you can clean it up, clean up both views. Removed is, I think it's kind of like a removed section. The same principle. If you can't fit a right side view of a part, or you want to basically show it at a different scale, because it looks like we're talking about what, half scale on the drawing and full scale here. Well, if it's aligned with, if this right side view is aligned with the front view, couldn't really show it in a different scale. But if you remove it, break the alignment and bring it up and put it in a different location, now you can change the scale and let it be whatever you want, because the view arrows tell you which direction you're looking at the part from in this view. So you can remove it just like you remove a section to make room, or in this case, change the scale, and then put it wherever you want in the drawing. So it's a view that's not aligned using the glass box method, and it's a space issue, or space and or the scale. So I noticed in my videos when I played them back that I do a lot of ums and ahs. They seem to really stand out. So I'll try to be conscious of that and minimize the amount of hesitation and umming and awing and awe and umming that I do. So it seems like a natural thing to do when you're searching for a word, you know. And but when I hear it on the playback, it just doesn't sound very good. So I won't be that YouTube sensation anytime soon. And there's an right there, right? It's really hard habit to break. Revolve the view. So not only is the view removed from the alignment, but it's also rotated or revolved, right? Because really this should be in the vertical position. Because, right, we're taking it from the right, you know, from the, we're looking at the right-hand side of the part. So it really should be vertical, but we don't have the space for that. If we want to dimension these as well, so by rotating it or revolving it and removing it, then we can accomplish that. And you don't have to keep it aligned. Actually, you couldn't revolve it and maintain alignment because it just wouldn't be right. So this is an option. Do you use it very often? probably not. The best thing to do would be to move to a bigger sheet size, and then put the views in the way they should be put in. And then you can probably change the scale also, so that you've got bigger views and you can mention them easier. So same rules as the revolved part, or I mean the removed part. Related parts. Sometimes there's a need to show a mating part in a even in a detail, because then you might have a better idea of how the part fits in the assembly, and if there are tolerances on some dimensions, it might give you a better idea of what the tolerances are actually doing. So if you want to make sure you've got a tight slit fit, well, I can't zoom in on this, but if you want to make sure, for example, you've got a tight slit fit between these two parts, and you've got a dimension between from here to here on the detail that is toleranced, then as a machinist you might be saying, well, what the heck are they tolerancing that for? It doesn't look like it needs it. Well, if you show the mating part, sometimes they get a better idea of what's going on. In SolidWorks, you usually have to create an assembly or a sub of some type, so that you can bring in views of the assembly into your detail, and then make this part, change the outline of this part to phantom, which is what that should be. It looks like it is. Change it to phantom line, so that you can show both parts together. Don't, to my knowledge, and that could be wrong, I don't believe there's a way to do that with just a single part view. I know as soon as I say that, I'm going to be wrong, but that's my story, and I'm sticking to it for now. I'll have to investigate that a little bit and let you know. But as far as I know, you would have to create a subassembly of these two parts, bring in views of that subassembly to detail it, and then either turn off the part in that that you don't want to show in the other views, and change the outline of the part in the view that you do want it to show. It's not that hard, but maybe there is a way to do it with a single part. I know you can bring in more than one part to a drawing, so I suppose it's possible. I'll let you know. The rest of this PowerPoint talks about different manufacturing practices like castings and welding. How well versed are we in these things? Bob, you got a pretty good handle on, or should I go through this?
Well, I've used castings in my work career, so I'm pretty good. But I don't know about Mike.
Yeah, Mike, what do you think?
I think I'm pretty good. The reading seemed to make sense to me.
Yeah, the reading was quite. Yeah, the reading of the book was quite clear. I will say that. Yeah,
and most of this stuff is based on the book anyway.
Right.
So they talk about the two parts of the mold, the parting lines. The draft maybe is you guys both understand draft and what that's all about.
Yes, makes it so it'll come out of the mold.
Yeah, exactly. You can't split the mold if the parts are overhanging. If the part's wider than at the top or the bottom than the mold is, then you can't separate the parts. So, and sometimes they have to cast parts that way, and so that's why they make multiple part molds, right? So you can split them and get the parts out when they've got oddball surfaces that go against the norm in terms of parting lines and draft. So yeah, it's all pretty straightforward. The difference, you get the difference between a corner radius and a fillet radius.
Yeah, the fillet's pretty much on the part between two surfaces where the corner is actually on the corner.
Yeah, the other thing is, you'll notice this in SolidWorks, especially when you assign material and you're looking at the mass of the part. When you do a fillet on an inner corner, you're adding material. When you do a corner radius, you're taking away material. So that's the main, to me, that's the main difference between a fillet radius and a corner radius. A fillet adds material, a corner takes away material. I don't believe there's anything in the quizzes or anything or such that ask you what the difference is between them. I don't really recall. What time is it? Because we're going to be crashing out of here in about 5 minutes too. So I'm going to just basically open the meeting again and let you guys sign back in, and then we'll go over the doing some auxiliary views and details in SolidWorks. You guys understand surface roughness, the surface finish symbol, and all that good stuff. You know, a lot of times there's numbers in here like 125 or 63, 32, 16. Those are designations of the actual surface finish. And as the numbers get smaller, the surface finish gets finer, and the cost goes up because in order to achieve it, you've got to go from machining to grinding to honing and polishing and things like that that take a lot of time. It's kind of like you know, painting a car. You paint it and it's rough, and then you start sanding with rough grit sandpaper, and you work your way down to super fine in order to remove all the scratches and get yourself a nice polished finish. Same thing. Welding, you know, we all know what welding is all about. You know, there's some people I'm sure in the class that have never. And you understand weld symbols?
Not really.
No. Okay.
No.
So maybe we should talk about them. Like I say, we're going to be out here shortly, but weld symbol basically tells you what type of weld it is. In this case, it's a fillet weld that we're putting on here. And if you notice the arrow, the symbol itself is on this side of the part, that side of the part, but there's no there's no weld there. There's no weld bead. So this is saying that it's on the opposite side of where we're pointing, which is why the weld bead is here. The 8 represents the length of the leg of the weld. This is the leg, right? Just like a 45 triangle, 2 legs in the hypotenuse.
Right.
So if it says 8 millimeters, that means this leg and this leg are 8 millimeters long. Or it's the effective throat. Effective throat is the distance from the apex to here. And I'll be honest with you, I don't recall. So if I were making the weld, I would go with effective throat, but I'm pretty sure it's the leg length. Leg equals 8 millimeters. So this would be the leg. But if you made the effective throat 8 millimeters, you're in a sense, essentially your weld would be bigger. Where's my countdown timer? It says we got about 2 minutes, right? Is that what you guys are seeing? So in this case here, we're saying it's a fillet weld. And on one side, the legs are 12 millimeters long. And on the opposite side, and on the arrow side, the legs are 6 millimeters long. Which is the part that's giving you an issue? Is it some of the, because basically you're just specifying groove or the type of weld or groove prep, in some cases. And then whether or not, you're, in this case, you're not specifying a length of the weld or whether it's a stitch or anything like that, but you can do that. And within the symbol, you can say how long the length of the bead is and what the distance is between beads. And we're not going to get into that, into it that hard. Basically just going to show you how to apply a weld symbol. This right here means that it's an all-around weld. So when you look at this weld, if you were to be able to rotate this part, this weld bead snakes underneath and then back up the side and over and then back down again and around and comes around like that. So it's all the way around, like a giant figure eight almost, that's folded over. Or an oval, I guess, maybe that's folded over. This one is indicating a V-groove. We're about done. We've got 5 seconds. We're going to get kicked out, and I'll reopen the meeting. Now it says the meeting will end in 10 minutes. Oh, we're getting our extra 10 minutes today.
All right.
Wow. So they're calling a V-groove weld. Basically what you're doing is if you're welding two flat pieces together, you are going to prep them by grinding a V or an angle on each one that creates a V when you put them together. That way when you weld, you start down here and you get full penetration, and then you keep adding material as you go along. So usually on welds like this, they're big enough and deep enough that you start with a small weld that joins the two parts and gives you full penetration for the length of the groove, whatever that is, along the part. And then you come back and you weld over the top of the first weld and fill it in some more, and then come back and fill it, however many passes it takes you to get this thing filled, so that you've got a full weld that's that's thicker than the material. And then you grind it down, both sides if you have to, in order for it to be flush. And then you've got what appears to be a single part that's made from two parts. Same thing applies if it's relatively thin material. You don't need to do a prep. All you need to do is space them apart. So it's called a square groove weld. Well, you're still going to do the same thing, except if it's thin material, you're probably going to be able to put enough heat into the two parts to create a full weld in a single pass. If you're going to have to make more than one pass, you're not going to want to do a weld like this. The only time you might be able to get away with it is if you're able to weld at least half of the material on one side, get half the depth, and weld it along the joint for the full length, flip the part over, and then weld the bottom half in the same way. But you got to make sure that you're getting full penetration. If you leave a little air pocket here for some reason, then the part's not going to be full strength. And if this were to be a piece that they were going to pull in a tensile testing machine, they would grip it on this end and this end, and they'd start to pull these two ends apart and see how much stress it takes in order for the part to separate. If it's a good weld, if it's a perfect weld, it'll be stronger than the original material. The part will break somewhere outside the weld. But if it's not a good weld, it's definitely going to break right here, and it's not going to, the tensile strength that results will not be equal to the material. So let's say it's mild steel and the tensile strength is 65,000 PSI, and you pull this thing and it breaks at 30,000, well, something will happen, and it's usually, you'll find when it pulls, you'll see an area in the middle where you didn't get penetration. I did a lot of welding, not as a job, but when I was in college, I was a lab assistant for the class, and there were a lot of welds that were done on specimens like this. We would actually do a double bevel weld, so we'd V this out here and V this out here, and have the students weld them up, and they'd weld one side and then they'd flip it over and weld the other side, and we'd pull them. And even with a nice prep like this, and you think you got a bunch of heat and you're getting good penetration, almost every one of them would break, and you would see a little bit of lack of penetration right at the very center. And the welds would always break, at lesser strength than the base material. So that's what you're doing. You're trying to tell the welder how you want the part welded. After all that. That's pretty much it. This thing, I don't know if are you still working on this P39?
I think I put mine up already.
Did you? I haven't looked at any of the assignments for it yet. But it still, I think, has a due date of April 1st. It's really not very hard. I pretty much showed everybody that was around how to create the section view and replace the top view with it. I mean, that's the, that and doing the dimensions the way the instructions tell you are the big deal. So, Mike, you're okay?
Yeah, I think I turned it in.
Okay. Okay. Well, you probably know better than I. Like I said, I haven't really looked at the assignments to grade anything yet. I just graded a couple of things so far. How much time we got? 5 minutes or 4 minutes, basically. Here's my part. Let's see what I got open. Here's the part that I'm going to do. I don't have a. Wrong one. I don't have a template pulled out, so I'm just going to use a standard template. And we're probably going to see some issues with the standard template. But that'll be okay. Be kind of like I did before, I think, with the dimensions the way they are. Notice it's showing origins everywhere. I don't want to shut everything off. I just want to shut off the origins. So get rid of them. Auxiliary view, view layout, auxiliary view. I just start the command and it says select a reference edge. All I got to do is select the edge that I want to create an auxiliary view from. And there it is. And you see it did a full view. This thing is actually, see if I can get it. It's actually 2 arrows. So I'm trying to get it separated. I don't know why it does this. Whoop. I want to make sure I'm looking at the part the right way. Well, it doesn't really matter. If you want it to be 2 arrows, you have to get it separated. But as long as you know which direction you're looking at it from. But notice that it's aligned. See that?
Right.
It's perfectly aligned. So if I wanted to break the alignment, I could. As long as I don't realign it somewhere else. I don't want to break the alignment and then bring this thing down in direct alignment here. But if I want to move it away a little bit so that I've got a little bit more room, that's okay. I can do that. So now that I've done that, I can dimension this hole and the radius, location, and all that. Whether or not it's great for machining it, I'm not 100% sure. But that's what I would probably do anyway. We're on our last minute. But that's how you do a auxiliary. If you wanted to crop this or do a partial, you'd have to crop it. So why don't I wait until, if you want to see that, let's wait until this thing kicks us out. And then hopefully Monday morning, Wednesday morning, I'll be, like shortly after midnight, I'll be buying, I'm going to just go ahead and buy buy into the 2 months worth of the pro version so that we don't have to deal with this. One of the other students wanted me to use Discord, which I looked at. It's a gamer's chat, and you can you can cast your screen and all that, but it looks a little more complicated. Okay. Are you with me?
I'm here.
Yeah, Mike's here. You're here, right, Mike?
Yep.
Okay. So if you wanted to create a partial on this auxiliary view, you would have to, I think, crop it. I don't believe there's any way to. Again, as soon as I say that, I'll probably find it. But I don't see anything in the property manager about changing the type of view that it is. You don't get the option to do a partial. So the easiest way I know how to do this is to do a crop view. And basically like cropping anything else. It says sketch a closed sketch profile in the drawing view to create a crop. So if I just even go ahead and create a box, let's say I just want to show this much of it. And then, so once I do that, basically to do a crop, you got to sketch the area you want to crop first. And then if I go back to view layout and say crop it, then it just went ahead and cropped it automatically. It picked up that sketch, and there it is. I could have made it a little more, look a little better with the lines being parallel. But that just gives you an idea. It's still view AA, but now we just got that much of it to show. And I can go ahead and throw dimensions on it and do all that good stuff. And like I said, when you look at the dimensions now, they look they don't look right, do they? So I need to go in here and check my units. I can leave my units alone maybe and go right to my drafting standard, which says it's ISO modified. Change that to ANSI. And then look at my dimensions and say, hey, I want all my dimensions to be 3 plays, just for grins. They don't have to be that, but leading and trailing zeros, I can pretty much leave like they are, I think. Leading zeros are standard, whatever the standard says, you don't show them in, for dimensions less than an inch. So once I'm good with that, I can go ahead and say, okay, and now my dimensions, read it. There we go. So there's my double arrows now. And I think that might have been part of the problem, was the fact that we were in ISO. And I kind of like the single arrow. And you see, I can't I can't merge them together. So if I'm going to do this, and I might as well show it like that, kind of. So it's showing like a partial. Because if I swing them together, that doesn't change the view at all. To the best of my knowledge, it's just pointing the direction out. It's not like a section view arrow where if I were to do a section view but shorten it up so that I was only cutting through the part way, then it would not be a full section. You understand what I'm saying about that? Okay. You too, Mike?
Yeah.
Okay. All right. Well, it's just, I don't know where everybody's at in terms of their experience with it. So, okay. So let's say we want to do a detail of, what should we detail? Let's say, let me look at this part. I want to do a cut through all. On that. When you've got a part, this is going to mate to something. You got a corner like that. Either the mating part has to have a chamfer on it, or this has to have some kind of a chamfer or whatever on it in order to create some space so that you don't have two sharp corners trying to mate. You understand what I'm saying?
I do.
Okay, so I just put a little clearance in there. I mean, it's not exactly the way it would be done, but I did it just so that I could show it in the drawing. So now I'd like to be able to dimension that. And maybe the best thing to do is to, instead of trying to dimension it on here, because I'm probably going to have a whole bunch of other things, I'm going to do a detail of it. So I go to View Layout, Detail View, and it kind of defaults to a circular boundary. I'm going to select the middle of this guy, and I'm going to pick enough so that I get that much of it. And of course, I don't quite have enough space for everything, but yeah, I'm just going to drop it right there for now. So that's my detail. I'm going to move this guy up a little bit. Yeah, I'm squished. This doesn't need to be that long, obviously. This doesn't need to be that long. So I'm trying to make a little more space for myself. I guess I could even maybe even do this. All right, since my view AA is not aligned, I can bring this out here. So now I could go ahead and dimension. Thought I hit that. Dimension this thing. Say I want to put the dimension to here. It's going to be the same as that because it was and then the diameter, whatever that is. It says radius, so I'll call it out as a diameter. And in order to change that, I just go to the liters tab on that dimension and change from liter to, from radius to diameter. And now I can see the diameter. So those are the three things that I kind of wanted to show you, how to update this title block or the template when it, especially if you wind up you won't in this class, but if you wind up using some of the defaults, you just kind of never know what they default to, whether it's ANSI or there's always been a case where there's always been a case when I open these templates that SolidWorks supplies, where I'll go into document properties and look at the drafting standard, and it'll say ANSI modified. But when I start looking at the dimensions individually, the overall drafting standard, or the drafting standard is ANSI modified, but the base drafting standard is for that dimension will still say ISO. And this might say ISO. And they all might say ISO, even though the overall says ANSI modified. I don't know why that is, but you have to double check that sometimes and make sure that everything is set correctly. You'd notice it, as soon as your dimensions started looking like something different than what the standard says they should be. So, any questions on that?
No.
Okay, so that's pretty straightforward. It's just a little bit of practice time to get them what you want. Like I said, these things look a little different. So notice again that it maintains the sequence for all these additional views. The first view we put in was the auxiliary view, so that was AA. And then we did the detail view, and that was detail B. If I were going to cut a section in this thing, it would be it's going to be section C, right? And if I what I was saying before is if I do something like that, and then rebuild it, you see it does a partial section now. It cut off, it's only cutting through to where the line ends, which you can't do with this, unfortunately. You can't create a partial auxiliary view by changing the arrows like you can with a section. That's what I was saying before. But you have that option with the section to basically change that section. You just have to remember, if you do it this way, you got to rebuild it in order for the change to take effect. And if you forget, at some point, it's going to rebuild anyway. So I don't have enough rooms to fit it all in there. So anything else? Is there anything that anybody wants, that either of you want to discuss that you're having any issues with? Nothing so far, right?
Yeah.
No.
I haven't figured out anything I needed clarification on. You're doing a good job between you and the book. We're doing great.
Well, unfortunately, I'm only hearing that from two of you. So
That's true. Unfortunately, probably the people who will need the help are the people who aren't showing up.
yeah, or I don't know what they're doing or what they expect. And I might the drop date is April 4th. I think it's the 4th. I think that's a Friday. It's in the syllabus, but it's possible that I might see a bunch of drops by that point too.
Yeah, the 4th is Saturday.
Oh, is it? Oh,
Yeah.
so maybe it's the 3rd. Sorry.
Oh, that's all right.
I was thinking it was. Yeah, because that's true. That's right, because Wednesday is April 1st.
Right.
Duh. Actually, I'm thinking it's like a month away, and it's really only 4 days away, isn't it?
Right.
So.
Yeah, we got Josh.
Hey, Josh. What happened, Josh? He's got his mic. Your mic is muted.
Sorry, I've been late. Wait, is it working? Yeah, it's working. Sorry, I'm late though. I was eating breakfast. I woke up at 10:30 by accident.
Wow. I'm glad you guys aren't working for me. Well, we're if you guys, Mike and Bob, if you're done, you can certainly opt out anytime you want. And I can kind of basically walk through this with Josh again. Josh, where are you at? I mean, what's your feeling on your competence level as far as working with SolidWorks? I just got through with demoing how to do some of these views on this part. It's kind of goes hand in hand with the reading in the book and the PowerPoints in terms of how to do some different advanced views like auxiliary views and details and things like that. It also talks about processes like casting, welding, things like that. Are you familiar with the casting process at all?
I am not, but I'll grab a notebook right now, right next to me.
All right. So maybe, I guess what I can do is not save this. I've already got the part done, more or less the way I want it for now. And just kind of maybe walk through the PowerPoint with him again. So I made I did do a recording of the first.
Oh, I can watch the recording then.
Yeah, I did do a recording. I haven't posted it. I'll have to post it to Facebook.
Oh, yeah, you are using OBS.
Well, you probably won't see what I did in SolidWorks for the most part. I think we did most of it during the second video, but that's being recorded as well. So it's up to you.
I'll watch the video.
I kind of figured. All right. Well, I guess, Bob, you're okay, obviously, right?
Yeah, I'm fine.
Yeah.
And that last video you did I enjoyed it. It was good to hear the second time. So,
Like I mean, as far as how to up and download?
well, no, the video, the lecture
video. Okay.
Yeah, I'm not using that version of SolidWorks.
You've got it on. You've got it
I've
loaded.
got it on my computer. So,
yeah. Josh, have you used the online version of SolidWorks?
I believe so. Yes, I've used SolidWorks at home.
Oh, do you have it loaded on your PC at home?
I don't have it turned on right now, but I do have it on. I have it.
Or are you using it through the AppStream app or portal?
I'm not too sure.
Okay.
I know that I do have it on my desktop.
Oh, well then you must have it loaded.
Yeah. Yeah.
You have if you have the SolidWorks icon on your desktop, then you've got it loaded on your PC.
All right. Yeah.
Okay. Well, then that's the easiest way to use it. So it should be good. All right. Well, if that's the case, then I'm going to I'll end the meeting. Let it. Or you guys can just opt out whenever you want. I want to make sure I save this. This first one somewhere where I can find it.
okay, Frank, I'll see you on Wednesday then.
All right. Yep, I'll be here.
All right.
I'll put it on my desktop. All right.
All right. I'll
bye.
try to show. I'll show up earlier next time.
No, that's okay. Well, all right. I'll get these videos up there as quick as I can.
All right. Thank you.
Yep.